Hello, everyone, and we're back with another episode of I Build at 4 a.m. Right now, for this episode, we have as a guest a very important person here, the brilliant mind that created the coprocessor, Carsten Munk, and that's what we're gonna talk about. So, before anything, I think our listeners would love to learn a little bit more about you, Carsten. Like, who's Carsten? What does he do? What does he eat? Where he goes? Where he lives? And a little bit of your journey on Web3, of course.
Yeah, so I'm a computer scientist by trade, and kind of like one of the things I've been doing for kind of like in the longest time in my life is basically open source projects. Like I did my first open source project at something like 14 or 15, and I basically then continued in this participating in online communities. I made a project that connected together people with the chat servers, a so-called ISE server. And then I did my computer science degree, did a lot of research, kind of like that, and so on. Then I kind of like started working with Nokia at some point, working on the Linux mobile devices. And then that evolved into like a startup called Java, where we were doing basically an alternative to Android in it. And at some point, I got bit by the blockchain bug. Because I could see at that point, being in mobile and having kind of see understanding how people were spending time with their mobile devices, how blockchain and decentralization and let's say the ability to do things without a middleman completely changed around or will change around how our experiences and so on work in mobile devices. So this was like 2015 something. So I have seen a lot of stuff in Web3 by now. I originally started by seeing, okay, so what can I do with like, oh, there's these new fancy things called smartwatches. And I wanted to do a smartwatch where you could send Bitcoin between each other, enter into smart contracts with Ethereum. Back then, Ethereum was still on testnet. Like the mainnet Ethereum had not launched at that point, and kind of like seeing with complete unlimited understanding of the actual constraints of a blockchain, what could actually, let's say, happen at that point. And that got me so excited that I went out and started my own company together with my co-founders, and basically focusing on what we could do as much as possible on mobile devices and Web3. And basically, it meant that we started playing with every single technology under the sun in Web3, including early stages of Umisigo, Plasma, Fuel in the early days, and a lot of kind of like different technologies that kind of like try to kind of like fix some of the scalability issues we were kind of seeing. So we've also built a few products. We were doing some things in Kenya, for example, where we had a small kind of like web wallet specifically made for mobile, low-powered mobiles that took up like something like 60,000 signups. How many of those were bots is still a little bit of a question mark, but anything about two and numbers these days. So we've got like been trying to see everything that's entirely possible with blockchain and understanding the constraints and understanding where the real problems of actual consumer and developer adoption are. So a lot of people kind of like think that I was kind of like along with Cartesi in the beginning, and I wasn't actually. I was just another community member that came in and started talking to this random guy called Carlo on the Cartesi Discord and starting kind of getting answers, response on documentation issues and issues running samples and so on. So some have kind of like described me as one of the first people that actually got excited about Cartesi.
What were the first things that actually interested you in Web3? Like, I know you tested many projects, as you mentioned, but like, what were the ones that hit somewhere to you that you felt like, okay, this is actually something that's interesting. I can try to play around it. It solves a problem. It solves an issue. That's something I can do.
Yeah. So obviously, like when I started, there wasn't really any projects outright. I mean, there was things like IPFS that was kind of emerging at that point. Ethereum itself was also emerging. Bitcoin, I had never been that terribly interested in because I like communities that don't seem outright hostile, and Bitcoin is a bit player versus player kind of environment once in a while when it comes to the dev environment. And initially, IPFS and Ethereum, like IPFS was actually, let's say, my first love in decentralization, and still is, because it enables people to publish data pretty much in a way where anybody can host it. There's no centralized servers, anything like that. It's very, very different concept when you previously were sitting in an environment where very, very strong middlemen were there. Like, for example, applications posting in app stores, taking a cut, very strong kind of like, let's say, almost monopolies and kind of like the people who make the devices. And so you kind of like start seeing this should be a freer market and much more open for applications and so on. So what attracted me is that, well, how do we get out of the duopoly of, for example, Apple and Android / Google in this particular case? And that's what attracted me to Web3, that there's a structural problem here where power could be decentralized.
Yeah, that makes total sense. I think personally, I do love your picks, and I do think that at some point we started actually seeing the inspiration from older protocols starting to get to new ones and enabling us to do better things. But as you mentioned, then you found Cartesi at some point as a community member. And what were your thoughts? What were the things that drew you to the project itself? Why was it special?
Okay. So at that particular point, let's say in my normal product work, I basically had the problem that most people have, which is that they start writing something they would like to have something done trustlessly. And that means writing a smart contract, right? And you very, very quickly start, after you have written a smart contract, so you start actually looking at the economics of the smart contract and even, let's say, the possibility to run things. And what essentially happened at that point was that we want to do something completely, let's say, for a normal computer, it wouldn't be a problem, right? But for, let's say, a small, almost Game Boy CPU-like, or even less capable smart contract network, it would be completely crazy. So you start looking at, okay, so what can we do with off-chain computation, right? So originally, I spent a lot of time with a project called TrueBit, which is kind of like the original, well, one of the original kind of like off-chain computation things, which existed way before all these ZK or even Cartesi and those kind of things, which basically tried to do this whole optimistic settlement game kind of thing, where you found kind of like the last possible point, and it was kind of like it was using WASM at that point, right? And it wasn't a particularly good WASM implementation, and it was very, very restricted, as in I could basically only stuff like, let's say, 1 gigabyte of data into it, and I wanted to stuff a lot more data into it. And then I started kind of like Googling around TrueBit and so on, and I found this completely crazy white paper from these guys called Cartesi, and like I'm like sitting and thinking like these guys are doing what? This and I remember saying to somebody at some point that these guys are like completely crazy, but it seems like a pretty good idea.
Well, did your idea of them change with time, at least?
Well, I would like to say that, let's say that craziness comes with creativity in this particular case. I think that actually it has proven more over time that it was the right direction in terms of using BISC-V, and it was using let's say the ability to run Linux on top of it. But there was still kind of like a lot of, let's say, milestones to be met to really be user friendly in that regard, because you have to remember I used to do embedded Linux, right? Like something like doing cross compilation or setting up dealing with a slow device or something like that. It's not news to me, right?
Yeah.
And that made me able to kind of like look from perspective of not being a smart contract developer, but just treating like this, like it's just another development board that I have on my desk. using Cartesi in that regard. But I can imagine for other people who tried Cartesi at the time, which is a number of years ago by now, it would have been a horrible experience for them, right?
Yep.
So that's kind of like how it goes sometimes.
I think there are a few sides to this coin, and like it's not Cartesi, it's Web3 as a whole. That it doesn't necessarily matter what language you're building into or what tool you're using. You still have to understand the basics and intricacies of Web3, like how tokens work, why deterministic computing, what are the limitations within that whole world. So this makes you still, even though you're using a familiar environment, have to learn so much about it and get a good grasp, a good understanding. It's not trivial for anyone who's beginning, but I remember people saying that you're like the first person that came to Cartesi, and without no one explaining to you anything, you actually understood what Cartesi was and what it was supposed to do. Back then, the product was Cartesi Compute, right? So how was the journey of all these developments of Cartesi Compute until what we have today on the coprocessor?
Yeah, so basically in the product we're doing at the time, we were using Cartesi Compute. And it was a bit of a interesting timeline also in terms of, let's say, what Cartesi itself was doing at the time, because the project had pretty much moved on to this new fancy thing they called roll-ups in this particular case, which was like on the roadmap. There was plenty of milestones and shipments and so on. But as a customer, I wanted something that works now, not in the future.
Yeah.
So we started using Cartesi Compute originally, and we managed to get some pretty cool stuff working with it at that point. But the problem was always that this stuff was deployed to mainnet. But as we kind of like started more talking to the Cartesi team in this particular case, they basically said, well, if it's good enough for you at this point, you can also deploy it yourself to mainnet. And I think I spent like $3,000 or something like that deploying Cartesi Compute for my kind of my own purposes back then. And it actually worked quite nicely. But we also started kind of like seeing where are kind of the gaps in doing compute here. And this was the first problem that like also feeds a little bit into the whole thing about coprocessor, which is that the first thing the developers are thinking about when they're doing smart contracts or things on blockchains, it's not, I'm going to do a roll-up. It's, I need to offload computation. And it's while people can understand something like, let's say there's networks, kind of things like Optimism out there, it is a bit of a leap in the amount of infrastructure and so on to things. So how compute evolved over time was basically that we started seeing the tendencies of things like EigenLayer merging, data availability protocols, and we kind of like saw a different angle to how could Cartesi Compute evolve as a product. And my company, CP, in this particular case, eventually got a grant to kind of like continue the development of Compute. And we found out over time, basically, there was more similar in terms of bindings, architecture, SDKs, and so on with, let's say, the roll-ups product that we kind of like threw out, let's say, this earlier version of Cartesi Compute and kind of started building something based on that, which then evolved into this Cartesi Coprocessor.
This is very nice. This is very good to know. And with the Cartesi Coprocessor, were you happy with the results? How do you think we position now from what we have now to the vision that you have had before?
Yeah, so vision always, let's say, clashes into reality at some point, right? And I think one thing that none of us really thought was that just how expensive, let's say, layer one would actually become for computation in many regards. And let's say the emergence of roll-ups as, let's say, the default place where people kind of like did things that were computationally expensive. I mean, it was clear that this was kind of like happening, but there hasn't been the whole complete unlock of developer freedom in this particular case. But where the coprocessors are at is quite close to how I think even Cartesi's own vision of the Cartesi Compute product was, but with the aspect that now we are doing things that are leveraging technologies like restaking and EigenLayer and so on, which changes around, let's say, the economics of things. It makes it much more generic, and it makes it much more practical to make something that is not, let's say, overly complex and easy to understand for developers to actually start using.
Talking about easy to understand, I'm gonna try and share my screen here real quick, just so we can get a little grasp on the architecture of the coprocessor, right? Which one do you think is the better picture to analyze?
Yeah, I need to like use my glasses a little bit because it's
Or
just
the
not so
data
big here.
flow
But yeah, I think
down.
this one is. I think the first one here is quite good
All right.
in this particular case. So basically, some people might have heard about, let's say, that there's these things called proven networks out there, or kind of like computation networks. And basically, this is what a coprocessor is, right? We have a bunch of operators, and operators is kind of like an, let's say, EigenLayer term for nodes in this particular case, but nodes normally imply there's some kind of network. And these nodes are essentially providing, each of them are providing the ability to get computation done for, let's say, in exchange for some value, right? So when you actually want to have something secure, you go out to a bunch of operators enough to kind of like get a strong enough secure feeling about it and say, oh, if all these operators actually agree, then it's very, very unlikely that they're dishonest, right? In this particular case. So basically, you can upload your computation, get it executed, get the results back. Where the coprocessor is a little bit different here is that we have these things called solvers, which are things that are listening to the Ethereum chain for actual work to be done. And then they then take care of actually talking to the operators, because like people typically don't want to run their own infrastructure to manage something on chain, because it's much better if there's just something where you can just upload to and it just handles. A little bit like how people prefer shared web hosts versus someone, let's say, having, let's say, their own that they need to administer and so on all the time. And also likely that these solvers can likely get better deals, or better, let's say, time spent or money spent for actually getting these computations done. This might be a little bit more easier to kind of like, let's say, explain a little more as we are going, for example, going to talk probably a little bit about EigenLayer, how this fits into this piece here. But essentially what it does is that your smart contract has something to be done as a computation. We have an off-chain network of operators handling this thing.
Yep.
Executing it, and basically then we just settle it back with all these signatures that these operators are saying back into your back into the Ethereum layer one, and then it calls your contract back with the outputs. So it's kind of like like let's say an asynchronous way to get off-chain computation done. And the reason why this works so well is because we use the Cartesi machine. So when we run this computation on every single operator, it will, unless they're being fraudulent or a solar array has got into them, something like that, they will basically be able to get the same result on all of them. And that's not given on, let's say, right amount of hardware.
I see. So the quick thing that instantly comes to mind is that not for Cartesi coprocessor, but coprocessors in general do have this similarity with oracles in a sense, in which you're delegating the knowledge to a different individual, right?
Yeah.
But the big difference is the security guarantees.
Yes. So in this particular case, like because people can go in and kind of like replicate the computation, it's a little bit different than Oracle, right? Like the only choice you have with an Oracle is that, let's say, all the other oracles in that network and all the participants say that you did something wrong, right? But with something like computation, you can actually go ahead and check yourself. This oracle actually, let's say, execute the right thing, like this operator to execute the right thing. It means then that basically this actual cryptoeconomic security backing this result that you're getting back, as in that someone will lose some amount of money if this computation is wrong, which kind of gives you security to actually protect value kind of like below this amount of money.
I see. Is there a way to improve that, to go even beyond what we have provided, like just from Eigen and from the whole, how can I say, a quorum idea?
Yeah. So of course that's kind of like scaling up with let's say with extra security in this regard, like let's say many operators and those kind of things, or combining with different technologies, like coming later with a ZK proof or something. There's many kind of like ways to kind of combine these things together, but we are focusing just now on operator. Of course, you can scale down as in doing a random sampling of these operators, so it's actually cheaper to do the execution. But that's pretty much about it at the moment. You can only basically add as much reconfirmation to a result as possible. Like it might be that you get from first a subsample very quickly, which might take, let's say, less than a second. Then you get from the whole network in 5 seconds. And it's a little bit like waiting for more and more blocks to be generated to confirm that your result was actually on a block. That if you are selling, let's say, an expensive sports car, you're fine to wait a little bit for total confirmation.
There's a balance then between cost and security and use. So the whole thing is that you have to pick the right format for that user experience, right?
Yeah.
Being customizable matters and really helps. What I want to take a step back and understand deeper how restaking takes a part of it, why it became such a hype word in the ecosystem, and what even is restaking? I think
Well,
it's
that is a very good question, right? So you have to remember a little bit about the, let's say, the time that restaking was kind of like made in. It was let's go back to, let's say, a couple of years ago, where the only way to launch a new blockchain network of any kind, like was typically it was like proof of stake, right? So either you had like proof of work, or you had proof of stake in this particular case. Proof of work meant you need to have a lot of hardware and a hashing function and those kind of things. It was kind of like hard to kind of like redirect to kind of like get by. Some people did things like bootstrapping security by merge mining with Bitcoin. But typical with proof of stake, this was the whole big thing about tokens, because typically you would have a new token for your network. You need to have the total amount of staked value of the token that these nodes then have as kind of like stake to be big enough value to actually kind of secure this stuff and so on. And getting your token to that amount of value it takes time, it takes marketing, it takes road mapping, it takes BD. It's a very high effort for something that is essentially a single tiny piece of software doing something. And as a technology builder, having been through that rodeo before, it's something that prevents you from rolling out new inventions very quickly, right? And a couple of years ago, and I can't remember exactly when, kind of like this EigenLayer kind of idea came along, which is basically that, well, in Ethereum, we already have these validators who are staking. They're probably going to keep on staking. Would it be possible to kind of like put what they're staking at, let's say, at additional risk, right? Because this is what staking is. It's putting something at risk that can be taken away from you, so you can be penalized in case, let's say, you do something wrong in the network, right? And the original idea, and maybe still is a little bit with EigenLayer, was essentially that building out a stable system for you as a validator, or using a staking token, for example, like Lido and those kind of things, and reusing that value to bootstrap a new network, right? Because as you know, you need to have 2/3, for example, of the total amount of stake to be able to say you have kind of like a quorum or consensus here, right? And EigenLayer was basically the promise that, hey, you don't need to do this whole BD marketing, token launch, like legal liability kind of thing. You can basically convince stakers, in this particular case, operators, which kind of like, let's say, groups of stakers, to put their stuff additionally at risk for your protocol. And they will be able to get an additional yield based on the fact they're already staking, right? Because their money is sitting idle, it's locked. And it's a very, very different exercise than, let's say, convincing people that your token might have value in the future, right? Because you're basically just trying to convince people to run software, and that your software is good enough, that it's secure enough, and that it will bring back value to you. So this is why EigenLayer is, let's say, very, very interesting in terms of deploying these things out. It has kind of like changed a little bit over time. Now we have things like the Eigen token and things like intersubjective, which I'm not going to dive into here because we have limited time today. But basically, the ability to very easily roll out these kind of like new technologies using new consensus algorithms. We can see this, for example, in Espresso, and they are now doing confirmation layer, I think. That they basically can go out and reuse the restaking to kind of like get good enough or very close to kind of like Ethereum level security for doing these things without necessarily needing to have a token that's as valuable as, let's say, the total amount of stake depth. And this is very, very different kind of company that emerge out of this because they can focus very strongly on being technical and not to pump their token, essentially.
That's great. You mentioned intersubjective slashing there. I had a talk with another the dev director for Eigen, in which he dips into it and gives it an explanation. So just a heads up here for anyone who wants to get a better understanding of what it is. Throw back to that episode. It's a very interesting discussion. But either way, I would like to understand also a little bit more about the journey of building something that big, like creating infra, for example, the coprocessor itself, which is something that you're used to. What are the trials and tribulations that you find on the way? How do you go from something conceptual to something real in this space? How do you grow your own project? How do you create something that actually has value, that actually wants to bring value and be really, really useful?
Yeah. So if we can, like, let's say, limit this question a little bit to making an ABS in this particular case, like which is an EigenLayer based service, then my own journey has of course been EigenLayer just came out. They had a test net of some kind, and as with any Web3 projects, all the samples were early stage. The documentation was not very documentation-ish, and things that you would expect to work didn't work. Those kind of things. So you spend more time in the beginning with a new technology than you would spend on building your actual business value, right? Because the Cartesi Coprocessor itself is actually not that big in terms of code. It's essentially a fancy wrapper on top of our fantastic Cartesi machine. It's a little bit of glue on top of it to basically make it easier to kind of like request computation, get paid for it, and those kind of things. That's not the challenging part here, right? The challenging part was that EigenLayer had to kind of evolve to the point where essentially now anybody can sit down with, let's say, Rust and the EigenLayer Rust SDK plus some pretty decent reference contracts and bootstrap an EDS on the testnet in a matter of weeks at this point, right? So really focusing on business value. Naturally, you also need to kind of like have very clear in your head how this is going to scale, because originally we had a whole concept with that, let's say, everything needs to be batched on Ethereum, and we have to deliver everything back in a batch on Ethereum, and it kind of like restricted our thinking a little bit, right? Because this is kind of like how the existing samples were kind of built in the EigenLayer. But once we kind of like our mind cleared about how EigenLayer actually works, like it's basically a glorious spreadsheet of operators, weights, and so on, and a little bit of slashing on top of it. So it's a little bit like a PvP game in Excel in many regards. Then it made us able to, let's say, significantly simplify the Coprocessor concept. So we already had kind of like back in, this was in Istanbul 2023, I think. Yeah,
November.
we already had like something that had used like Cosmos SDK plus getting public keys from EigenLayer and so on. But it was not really exactly how it was supposed to be, and we didn't have some of the changes with kind of like very nice findings of Cartesi machine and those kind of things. So kind of like things matured over time to kind of get to this point with the coprocessor. Everything else then comes down to that you need to put this into a state where developers can adopt it, right? And we of course have benefit with that. We have already a quite good Cartesi SDK to kind of like make things work with it. And then combining that with writing documentation and samples, and kind of getting it into the point where you could sit these people down with this set up documentation and actually being able to produce something useful for the coprocessor. And you encounter, as you're eating dog food, you encounter issues that you have not thought about in this particular case. And you are then able to basically get to a point where, well, you could actually start suggesting your friend to start trying this software out. And then, of course, now the kind of like next step then comes into, well, if people can build with this, like, for example, people did in the Cartesi plus EigenLayer experiment week, then what can we find out of people that have actual pains that the coprocessor then solves? And this is kind of like my own belief is essentially that because I come myself from, let's say, product trying to use Cartesi, right? In terms of, let's say, a customer, I would like to say that this pain of smart contract scalability has not disappeared. We have had, let's say, good innovations like, let's say, Arbitrum stylus and a couple of ZK stuff and so on. But nothing really kind of like gets to the point which Cartesi does, which is very, very simply using, let's say, not so much additional information about blockchain or about Cartesi itself. Nothing really meets that at the moment. So at least I would like to believe that the Cartesi coprocessor with strong economics, crypto-economic security can actually solve real pain for people out there.
I see the coprocessor having this feeling where, differently from rollups, if you're using the coprocessor, you already took a step inside smart contract development. So you already have basis. You understand the little tiny pieces and the tiny parts that are intricate from Web3 that you have to understand to be able to actually create a Web3 application, right?
Mm-hmm.
So you already broke the first barrier. So in a sense, it's a product that is there for people who already know what they want to do. So it's just empowering. That it's just that I think that for its target, it has a lower barrier. I don't know if you agree with me in that sense, in that regard.
Yeah, I definitely agree with it. Like it's a little bit like with the roll-ups, like it's a little bit like you need to take the whole package, right? So with let's say if you're basing something on Upstack and rolling your own roll up out yourself, for example, or at Arbitrum, you kind of need to take the whole package and kind of like work with that. And you need to design things with specifically that. You kind of need to maintain everything yourself. Versus with the coprocessor, it's possible to just basically taste, right? It's something where you don't need to, let's say, marry the coprocessor directly, but you can start using it for things that start solving it. I do believe, of course, that eventually we get to a point where practically people's designs look closer to like almost like RISC-V smart contracts. But that has always been blockchain's problem, right? To some extent, that some things are too much of a leap from ordinary development, which includes smart contract only in this particular case, that people just don't adapt it because they see that, let's say, it's a too big chasm for them to jump over. Versus something like the coprocessor then actually allows people to fix a particular problem they have without asking them to completely buy in.
Fair. And in that regard of people developing, you also commented on it. There was the Cartesi Coprocessor with EigenLayer experiment week, where core contributors from Cartesi, guests, were able to actually participate in this mini hackathon. 1 week hackathon, actually, not so mini, but it was very nice and lots of products came out of it. Things leveraging AI, games, DeFi, art. Are there any products from there that, in your mind, have a lot of potential? Do you find any specific of those interesting? What do you see in the future for them?
So, of course, one of the things I paid a lot of attention to was, for example, the things that were not built by the core contributors. We had this Cartesi Lido thing, which basically takes a really, really hard problem, even for ZK, which is to calculate the total amount of stakes that are in Lido and calculating how the, let's say, the staking token should actually be valued or like amount, which is from the Ethereum Beacon chain. And it's something that is such a massive computation that, let's say, it would be too slow on ZK. At least that's how I understood it. I like seeing when people do things that are like, let's say, one of the things was like this Pokemon battle game thing. I can't remember exactly. That actually shows something straightforward that would be completely crazy to try and implement Solidity, being a good experience and being done pretty much completely on chain. And this basically shows that some of the, let's say, more playful things that we used to kind of like do back in 2018, like, let's say, things like CryptoKitties and so on, like they should have been a lot easier in practice, right? Like a lot of things like, let's say, generation of how these cats look like and so on should be really have been done on chain. Curiously, like my own project, which was about kind of like making NFTs automatically on chain, was actually the original plan, like, let's say, for myself to kind of like build something with Cartesi way back, because we are looking before people kind of started doing more smart contract like generative art and so on. We were trying to put Rust inside WASM, and we actually back then already ran, let's say, WASM interpreter in Cartesi and trying to build NFT kind of like stuff on top of it. So it's kind of like fun to sit down and see how the technology has progressed to a point where something that seemed completely crazy before, like making GIF animated generative art that actually NFTizes itself. It has become so easy that you basically can sit and do it with an AI editor, right?
This is amazing. I love these solutions as well, and I'm really looking forward to see what we can cook on top of them and how we can take them forward. What about exciting features, experiments that you want to do with the coprocessor still? Any way you're thinking about developing it? Some sneak peek that you can give to the listeners?
Yeah, so I think that with the coprocessor, like now you get into the, let's say, the boring part, right? Like you have proven it works, you have proven that people can build something exciting with it. Now you need to productize it, right? Which means security audits, it means roadmaps, it means getting things stable out there, deployed on mainnet. Because once you have proven that there's value for it for people, then it basically comes down to stabilizing that, and then once you've done that, taking a good vacation, then you come back and do crazy things on top of it, right? So that's kind of like the thing that you shouldn't let yourself get distracted with what can be done on top of it until you have something that's stable enough to actually support the crazy things you want to build. But one of the things I'm really excited about is that we are working to now kind of like organize and work towards having at least 50 builders for the Cartesi Coprocessor community, for Cartesi Coprocessor in this particular case. And really, the thing I really love about open source is when you put a product out there, people start showing up, people start helping each other, people start not necessarily contributing to the product, but just using the product, talking to each other about using the product, those kind of things. I really look forward to kind of see how that plays out in practice. I remember getting support from, for example, Nick from ENS back in the old days on stupid facility stuff and so on. And once you actually get that feeling that you're not alone in all these struggles, it is a completely different journey for you that basically enables you to kind of build amazing things in practice. And also for the people who made it, like it's amazing to sit and watch.
That's amazing. Actually, I think that's where open source goes right. And that's where Cartesi went right, going fully open source. It's great to see, for the community to see the core developers creating something they believe in, and then allowing the community to help each other and having the support and this huge growth. So I want, before us to finish, to move to a quick section we have right here. It's called a rapid fire, where I propose a bunch of really quick questions to you, and you reply without even thinking, like one word, one sentence. You can think a little bit, but just a tiny little bit. And some of these questions are made by the production, so some of them are a surprise to me as well. Anyway, let's go. So what's your favorite programming language of all time?
I think that there's these crazy one instruction set CPUs, and there's one called sublec, which is basically single instruction programming language, essentially assembly and machine code, and it's like it's Turing complete, and it's usable in so many crazy areas. Like you might not know this, but the first verification game in Cartesi was actually sublec.
Wow,
If you go and look at the Solidity code, you will actually find that in the Git history.
that's interesting. I had no idea about it.
Because you can combine everything down to it, and people have built a RISC-V person microcode processor on top of it.
That's amazing. I have to look into it. What's one Web 2 concept you wish more Web3 developers understood?
I think Web3 people have not fully understood what you can actually do in a reasonable, easy deployment way in cloud these days. And I've wished that Web3 developers actually spend a little bit of time understanding that we don't live back in, let's say, the 80s in terms of textbooks and tooling and those kind of things.
That's good. So coffee, tea, or mate?
Well, since my coffee machine broke down the other week, I would say coffee, because it was like almost mental breakdown causing for me that this happened.
Fair. What's a dream project you would build with unlimited time and budget? It cannot be the coprocessor. Okay.
Yeah, I have a stupid idea to implement a working with 5 coprocessor, not coprocessor, processor in Minecraft.
That's nice. You are almost there already. Most mind-blowing use case you've seen for the coprocessor so far?
I think with the Pokemon game at this particular point, like it's something that I didn't really foresee people would build during it, but I'm happy to see the ease of it.
One person in Web3 that everyone should be following.
Well, I think everybody's kind of like following her already, but I think Jill from Espresso, in this particular case, because she's tweeting a lot, and a lot is not afraid to kind of take punches.
Yeah, no, she's brilliant. I love Jill's X. If you could instantly master one new skill, technical or not, what would it be?
Probably the ability to put up lamps at home. I am not a very practical person or anything like that. No.
Give me 3 emojis that describe your vibe right now.
6 penguins in a row.
That's nice. Now, the secret question that I have for you, this was not production. Who's your favorite developer advocate from Cartesi that's 6 foot tall and hosts a bi-weekly podcast?
Well, I'm from a civilized country, so I have no idea what feet means. But of course,
okay.
Joao,
184 centimeters. All right, that's perfect, Carsten. Thank you very much. And one last question: if someone's listening and wants to start building with the coprocessor, what's the best way to begin?
Yeah, so I think right now the best way to go is to docs Mugen builders and click the Cartesi Coprocessor.
All right.
Hopefully we'll also get it on docs.cartesi.io, but for now that's where it's the best place.
Yes, we're taking care of that, and soon enough we'll get it in the official documentation. So be ready, and some nice things happening, right? Cartesi Coprocessor CLI being merged with the main CLI. So this is going to be interesting. I'm really looking forward to this enhanced journey.
Thank you.
Yeah, thank you. So this was iBuilder 4 AM. Thank you so much for being here, Carsten, and keep building and pioneering the world of Web3. Bye-bye.